Meron tayo ditong bagong motor. Ay, ano na naman yan? Ito ay tinatawag na 365 DC motor. Yung size niya 365. Ay, ano na naman yan? Aba, siya ay 12 volts. Kaya gagamitan natin ng motorcycle battery. Baterya ng motor. 12 volts yan. Tingnan natin kung anong voltahe ng battery. 12 volts DC. Positive sa positive. Negative sa negative. .25 volts DC. Okay pa siya. 12 volts. Motor, paikutin natin using battery. Kasi siya ay 12 volts. Positive. Positive. Ano ito? Ayan o. Umiikot siya, di ba? Pero hindi natin makita. Lagyan natin ng tape. Siyempre. Okay? Counterclockwise. Pag biniliktad natin, clockwise na siya. Di ba? Oh. Tingnan natin kung anong amperahe ng motor pag walang tape. Gamitan natin ang tester. Ampere DC. Yun. Tingnan natin kung anong amperahe niya. Ayun o. 0.149 ampere. Yung motor with no load. Wala siyang load. Pag nilagyan natin ng tape, .71 pag may tape. Tingnan natin kung ano yung stall current niya pag na-stack up. Ampere. 2.23. So pag na-stack up siya, 2.23 ampere. Oh, 2.2 ampere pag ni-stack up. So, yan ang current rating ng motor natin. 12 volts siya na 140. Pag walang tape. $146. Let us now see the figure 1, which is the motor test of our 365 motor size. So this is a 365 motor we use in our we're going to use in our project. Our project is we're using 12 volts DC from the motorcycle battery, 12 volts, and then we connected the tester in series to the load, since we're using the tester as ammeter or reading the current or the ampere reading of the circuit. And then connected is the motor, positive to the negative. This is the standard or the conventional current flow, clockwise. From our test, we have this at no load. Okay? Our motor with no load, we have this 0.146 ampere of current from the ammeter reading without the load, and it is different from motor with load. With load, it means we are using this as for example as an electric fan or anything that is with the load. But here we don't have the load, so the current is 0.146 ampere, and we jump the motor by holding the shaft. Jamming the motor, we can get the stall current while jamming the motor or motor jam, and it has a 2.23 ampere. When the motor is going to be stuck up or jammed or stalled, by holding the shaft of the motor, we stop the spinning of the motor by holding the shaft. So we got 2.23 ampere. We can change the direction of the motor by interchanging the polarity of the motor, interchanging the terminal of the motor. Okay? Ito na ang ating project. Meron tayong motor, may battery. Ito yung ating module. Ay, ano naman ang gagawin mo dyan? Oh. Tingnan mo ha. Pag pinindot ko yan, malakas yung sipa ng motor, di ba? Once na gamitan natin ng module, ito. Wala na siyang kick, wala nang sipa ng motor, Diba? Mabagal siyang mag-on at mabagal ding mag-off. Samantalang kung walang module, di ba? Malakas yung kick ng motor. Pag nilagyan natin pag may module using the MOSFET, Dandahan ding namamatay yung LED indicator. Yan o. Ba? We have now the schematic diagram of our project. We're using a MOSFET, a DC motor 365, switches, LED, diode, capacitor, resistor, and what is the purpose of soft start? Why is it we need to construct this type of module? In our testing, we have two push button. The first one is with this motor directly connected to the voltage supply and then to the switch. Voltage supply 12 volts, the motor, and then the switch. When we press the switch, current flows into the motor and then it goes to the ground, causing the motor to rotate. And what will happen to the motor? It will kick. The motor is kicking, and also the current flows into the green LED. That is the indicator that we are now turning on the motor. And what's the use of this diode? This is for back EMF eliminator. So when we press the switch, motor turns on. So it will run the motor, but with a large kick. It is kicking, and because of that, it has a large amount of inrush current. There is an inrush current when you connect the motor directly to the switch. That's why we are now building this module, this second set of a module, second set with a switch using a MOSFET to eliminate inrush current causing the motor to kick. There's a large vibration developed across the motor due to the inrush current. That's why we have this new set of circuit, which is now the soft start DC motor, soft starter. So the starting point of the motor is soft. It is not hard, soft. So here, since we have this power indicator and then we have the switch, how we will turn on the motor, how to run the motor by using the MOSFET. We need the voltage across the gate. We need to have a voltage here so that the MOSFET will turn on, making the motor to rotate or to move or to run we need the voltage across the gate, and it is only possible by pressing the switch 1. When we press it, current flows into the R1 1 mega ohms, and then charging this capacitor 10 microfarad 50 volts. So while charging, and of course there's a voltage developed across this capacitor around if it has a threshold voltage of around 2 volts developed, because we are now charging the capacitor, and now there's a 2 volts voltage, 2 volts develop across the capacitor. It will now switching on the MOSFET. By switching on the MOSFET, the motor will now start running, because the current flows into the motor, positive, negative, to the drain, to the source, and then to the ground. So the MOSFET serves as a switch. What kind of switching? It is low side switching, because we're pulling the MOSFET to the ground, pulling down the MOSFET to the ground. So low side switching, and the load is in the high side or from the source. Because of that, charging the capacitor, there's a voltage now at the gate, also with the capacitor. Now the motor starts to run, and then also LED turns on, this green LED. The current flows into the LED and then to the drain, to the source. The motor starts to run from positive to negative, drain to the source, and the MOSFET turns on. And as you are keep on pressing the switch, it will continue charging the capacitor. At the same time, it starts rotating the motor. And if you release the switch, this is now the supply that serves as the supply to the circuit, to the MOSFET. It will discharge through this resistor R2 and also to the gate to source, and slowly discharging this, causing the motor to stop slowly. So it starts slowly, then stop slowly. So that is the function of the module, to delay the motor, to avoid delay the motor from running, to delay. It serves as a delay on timer switch, because it takes time to charge this capacitor. At the same time, it takes time to discharge. So when you release the switch, it will discharge through this resistor, and then there's no charge. The capacitor will now discharge. So when you press it again, it starts charging again the capacitor, which switching on this MOSFET. Current flows into the motors. Now motor is rotating. Also the LED turns on, this green LED, because the current flows from drain to source. This will now serve as a switch. Okay, so because of that, this kind of a delay on timer is incremental type. What do I mean by incremental is, as long as you keep on pressing the switch, you are adding more charge. You are charging the capacitor, and if you release the switch and then press it again, it will increase the charge of the capacitor. It adds on the charge, or it will increase the charging of the capacitor. as long as you press the switch. And when you release it, it will serve as the supply going to the discharge capacitor and then to the gate of the source, causing the motor to move. That's why the motor now is we don't have now the inrush current because of this soft start, because of the delay produced by the circuit, or we call that a soft starter. And what's the use of the diode? This flyback diode serve us to counter the back EMF or the voltage developed. Since this is a coil, once you release the switch and the motor stops from running, there is a voltage developed across the motor, and it will, in order to eliminate the back EMF, or there's an EMF produced, a voltage induced inside the coil, it will start to, so in order to eliminate that, the back EMF, we need this flyback diode, so that the current will flow into the diode continuously, until it dissipate, or until it vanish, dissipate, because there's a voltage developed across the coil of the motor once we release the switch, a back EMF. So this is a protection. It's a protection. You can only see the fading of the LED. That is the indication that we press the button. So all in all, they serve as a delay on. It introduces a delay to the circuit in order to eliminate the inrush current. So the motor will not kick, or will not move, will not vibrate, because of this module, soft starter. So this is incremental. It means as long as you keep on pressing the switch, it will continue charging the capacitor. When you release it, it will now start discharging. When you press it again, it will start charging again and again, and then it will discharge once you release the switch. Discharging, charging, discharging, charging, discharging. So the motor will slowly go on, or cease to stop, or it will stop slowly, or it will not kick, or it will not develop an inrush current because of the capacitor of the circuit.